first click on create new circuit. So we are going to study about combinational clipper. This is the circuit diagram for combinational clipper. We have an input supply, that is AC sine wave. We have a resistor. We have two diodes. One is connected where the positive is attached to the positive first and negative is attached to the negative. It will get reversed when the cycle is negative, and this diode is attached opposite to this, and we have attached two external power supplies. So according to this, we can control the clipping of the diodes. So earlier we have studied about just the clipper where the clipping is constant, but in this combinational clipper we can vary the clipping size also. So let's move towards making this. So the components will require, first we'll take a breadboard, search the breadboard. Then we'll go for input power supply, that is require oscilloscope for the AC supply. We'll require two diodes. Copy paste. We'll require a resistor. For output, we'll require an oscilloscope. We'll require two power supply also. Power supply, this is DC power supply. Just a few components you'll require. Now moving towards the attachment of the circuitry. This is the input supply. Positive supply, I'll attach it over here. Move this. Positive supply, and negative, I'll make this common ground. You can change the color. From here. I'll make it black. I'll attach the diodes. Before that, you have a resistor. The resistor I've taken of 1 kilo ohms. I'll rotate it. I'll attach a resistor over here. Then we'll require two diodes, one with positive the upper side, negative below, and the other diode first in opposite direction. We'll make the attachments. This positive supply first is given to the resistor. This color green. I'll create red. Color doesn't matter, just for the representation purpose. I have diode. This terminal of diode is attached to the resistor. I'll do the connection like this. And these two diodes are attached to each other. The connection like this. This is attached to the diode, and this diode two are attached. Positive is attached to the negative. And from here we have taken the output. You can either keep this here, the input supply, or the output. From here we are taking the output. Just keep this part as the output. Positive terminal, attach the here and take the output. You can attach this terminal directly over here also, and negative terminal this to the common ground which we have already taken. This color black, this one red. Now we have to attach to power supply below here. So positive is attached to the negative and negative is attached to the ground. Power supplies. It is attached to this negative terminal. As negative terminal. And this negative terminal is attached to the ground. For this also, as you can see, the second power supply, negative terminal is attached to the positive negative terminal, attached here the positive, and the positive terminal is attached to the ground. So the connections are done. We have the input supply, the output will be here. You can check the input also. If you want to just check the input, what supply we are providing, you can attach one more oscilloscope at the input side, where positive will be attached to the positive and negative terminal is attached to the negative. This will just give me the input supply. Our connections are done. Just change this DC offset to 0, change to sine wave, frequency can change. First I'll keep it 500. You can change it as per your output requirements. Just start the simulation and check. I'll keep this voltages first to 0 for both. This also voltage to 0. Start the simulation. The voltage supply just to 4 milliseconds. As you can see, as we have changed, we are getting the proper output. More you have to reduce the frequency, so this width will increase. I'll reduce the frequency to around 400. Let's see how is the input and output. And reduce it lower, just to 100. Okay, so now you can get the clear image. This is the input, which is sine wave, and this is the output. Right now, if you can just compare, this is 10 volts. So this one block is 1 volts, 2 volts, 3 volts, 4 volts, 5 volts, and bottom also it is 5 volts. So the sine wave height is around 2.5 volts. This height is around 2.5 volts, and here you can see the output. The both the peaks are clipped. This is 2 volts, so this total height is around 1 volts. This is 1 volts, this is 1 volt, so this is around So this will be half, so this is 0.5 volts. So this peak is around 0.5 volts. So it is almost to zero, as the total both the peaks are clipped, as this voltage is zero. If you notice, if I increase this voltage slightly, increase this voltage, so now the positive peak is totally there, negative peak is clipped. Now this has changed to 10 volts. So now these two input and output are similar. Just take this close, we will get good view. Now the input and output are on the same scale. As you can see, the positive peak is steady and negative peak is clipped. So with this, I'm controlling the positive peak. Now if I increase this voltage, if I increase it slowly, you can see the negative peak is changing. So with this voltage, we can control the negative clipping. We can change the amplitude of the negative clipping. Increasing, I am increasing to maximum. So this is the full negative peak is there. This is same to the input voltage. Now if I change this voltage across this diode, so you can see the positive peak is changed. So the clipping amplitude changes with this voltage. So you can change the clipping amplitude. I'll just mark this. I'll mark this voltage as V1. I'll mark this voltage as V2. This will be the input supply. So I'll mark it as Vin. Now for the readings of combinational clipper, I'll just start the simulation first. So this is our input supply. We are providing 5 volts. This division is of 10 volts. So this is positive 5 volts. This is negative 5 volts. If I calculate the total height, the amplitude will be 10 volts. Now according to this output, you can see this division is of just 2 volts. Okay. So this is plus 2 volts. This is minus 2 volts. So this is plus 2 volts. So this is 1 volts, 2 volts. This total division is of 2 volts. So this part till half it is 1 volts, and till here it is 2 volts. So this will be around 1 volts. And if I just calculate the whole amplitude, it will be 2 volts. So you can see the positive peak is also clipped, negative peak is also clipped when both the power supply output are 0. Now according to our observation table, first I'll just calculate the input Vin, that is the input supply. The input voltage will be 10 volts. The total amplitude is 10. So I'll write 10 volts. And Vout as per our observation table, as I said, this is 2 volts, this is minus 2 volts, total height, this is division of 2 volts. So this will be 1 volts, this will be 1 volts, plus 1 volt, minus 1 volt. The total amplitude will be 2 volts. So Vout is 2 volts. Now according to the observation table, we have to calculate Vin less than V1. Vin is less than V1. This is Vin. This is V1. Before moving forward, I'll just show you how if I vary the power supply, this clipping will vary. So if I increase some voltage here, so this is positive peak is there, negative is almost 0. So it is around 0.7 volts is there. So that requires to on the diode. Now if I increase this a little bit, you can notice the negative clip is changing. So with this we can control the negative clipping. If I keep this voltage here, make this 0, the positive peak is clipped. The voltage, some voltage which is that is 0.7 volts, which requires to on the diode. If I increase this, you can notice the positive peak is changed. So first I'll keep this to 0. We want V in is less than V1. V in is constant, V in is less than V1. So V1 I'll make it greater than 5 volts. I'll keep it greater than 5 volts. Now the total amplitude will be, this is 10 divisions, this is also 10 divisions, so now it is same. So this will be 1, 2, 3 of 5 volts. This will be, as this is plus 5 minus 5, this will be 5 volts, and this will be around 1, 2, this is 10, total 10 division, so this will be 1. So this is around 6 volts. Now when V in is greater than V1, V in is greater than V1, so I'll lower this. And V2 is greater than V in, so I'll make it above 5. So this is how we get the voltage. This is same, but this will be around minus 6 volts, or you can write minus 5 volts as well. This is 10 volts, this is half of it. You can write this as minus 6 volts. So output voltage minus 6 or 6 volts is fine. Now when V in is greater than V2, V in is greater than V2, I'll lower this. V in is greater than V2, I'll keep this around 4 volts. You can keep it anywhere between. So here also you get around minus 6 volts. So for this table, you can just again we'll calculate V in is greater than V1. V in is greater than V1. We'll keep this voltage sum. We'll keep this around 4, and we'll keep this greater than 5. So this voltage will calculate. So this will be same as this. So that will be 10. So this is how our table will be. Now to draw the graph for combinational clipper, y-axis will be voltage, x-axis will be frequency or time. Here we'll draw the input signal, here we'll draw the output signal. Now input signal will be same, that is the sine wave. We'll be drawing combinational clipper. So input signal, sine wave, amplitude and width should be constant. 0 pi, 2 pi, 3 pi. Just marking the width. Now in combinational clipper, as you know, positive and negative, both the peaks are clipped, and we can adjust them. So I'll draw this lightly and then I'll draw it dark. This will be dotted as this part is clipped. This is negative, dotted part, this is dark, the dotted part, and this is dark. So I'll join this dark. So this is the clipped part. Positive and negative, both the peaks are clipped. In combinational clipper, we can adjust them. Thank you for watching. Do subscribe to my channel. If you have any doubts, any queries, let me know in the comment section.